Okay, here we go. Common factoring. So let's start off with a little review of what we did the other day, greatest common factor, because we're into factoring here. So let's write the number 20 as a product in as many ways as possible. So there's always one end itself, right, even if the number is prime, which this isn't. So 2 times 10. 3 doesn't go in, 4 does, 4 times 5. And then we'll start repeating actually, right? 5 goes in, but it will be 5 times 4, and then 10 times 2, and that. So that's the way that we can do 20. Now, we're going to write the prime factorization and a factor tree. So this is 2 times 10. 2 is prime. So we're supposed to circle that. There we go, circle. And 10 is 2 times 5. And both of those are primes. So remember we factor down a tree, we circle the primes. So 20 is 2 times 2 times 5, or 2 squared times 5. 28, 2 and 14. 2 is prime, so we circle. 14 is 2 prime times 7 prime. So 28 is 2 times 2 times 7, or 28 is 2 squared times 7. Let's just fill that in there. So the greatest common factor, oh wait, here we go, 20 is 2 squared times 5. 28 is 2 squared times 7. So what's common? The 2 squared. And so the greatest common factor is 2 squared, which is 4. So far, we've learned to write numbers as a product of their factors. But what are we going to do with a polynomial? So remember, a polynomial is in factored form when it's written as a product of 2 or more factors. So 3 times x minus 2, that's monomial times binomial. This is 2 binomials. Remember, we're going to get 4 products: FOIL, first, outer, inner, last, and then we'll collect like terms. And then this is a monomial times the product of 2 binomials. We know that this product will give us a trinomial, and then we'll multiply by 2x. And since we're only multiplying one term, we'll end up with another trinomial. In this course, we will only look at factoring polynomials by recognizing any common factors. So that's today, common factors of polynomials with more than one term. Since if it has one term, then there's really not much you can do to factor it, other than write it as a product, I guess. Of the form x squared plus bx plus c, of the form ax squared plus bx plus c, and that are a difference of squares. And an example of that is x squared minus y squared. Difference of squares is always in this form. Two terms, both of which are squares, since they have square roots, with a minus sign in between. That's the difference. Today, we're going to focus on recognizing any common factors of polynomials with more than one term. So to start with, we can take 6x squared. That's just a monomial, and write it as many ways as possible. So I could go 6 times x squared. I could go 6x times x. I could go 3 times 2x squared, or times x squared. I could go 3x times 2x. I guess we could go down here. Well, I mean, writing x times 6x is the same as writing 6x times x, so I'm not going to write this as 2x times 3x. But I could write it as 2 times 3x squared. Okay, that's unique. What else? Because 6 can be written as 1 times 6, or 2 times 3. So there might be more, but I've got a few there. Write the binomial 6x squared plus 12 in as many ways as possible. So I could go 2 times 3x squared plus 6. And you notice all I've done is divide each of these by 2. I could divide them by 3. 3 and 3 times 2x squared plus, this will have to be a 4. I can dividing by 1 doesn't really get us anything. We would just rewrite this. I can divide by 6, and that gives me x squared plus, and 6 times what? I always look at it this way. It's 6 times what is going to give me 12, 6 times 2. And really what I'm doing is taking 12 divided by 6. You notice there's a monomial out front, 1 term times 2 terms, and there must be 2 terms in the bracket so that the expansion will give us 2 terms, give us back these. Can I do anything else? I've got a 2 in front. I think that's about it. Which would be factored completely. So in factoring completely, we want to look at the brackets and say, hey, is there anything still in common? Like, I could divide these by 3. I could divide these by 2, and I can't divide these by any. So the complete factorization of 6x squared plus 12 is equal to 6x squared plus 2. Expand it out, 6x squared plus 12. Get used to doing that. Anytime you factor, you think you factored, then just quickly expand it out. Just make sure that it really is equal to what we originally started with. When we do prime factorization of numbers, we stop when we have an individual factor as a prime number. With an algebraic expression, it's said to be factored completely if each individual factor with more than one term, right? This only has one term. There's nothing you can do with this. If each individual factor with more than one term cannot be factored further. Okay? This can be, because you can factor a 3 out of that expression, a 2 out of that expression, and this one is done. In order to factor a polynomial, it's an algebraic expression, right? This we call polynomials or algebraic expressions. Completely, the first step is to look for the greatest common factor of all the individual terms. And this, really important, no matter what kind of factoring you're doing, the first step is always to look for the greatest common factor of the individual terms. Often say that as common factor first. Okay, greatest common factor of 20a squared and 28. Well, remember earlier we did the greatest common, the number is 4. And now we look at the variables and we say, well, do they have common? Yes, they do. They have an a in common. And so we're going to take the lowest power of a. Since it will go into this, okay, now we put down a bracket. Oh, sorry, actually we're done because we're going to use that down here. Okay, so 4a is common to, it will divide into 20a squared. It will divide into 28ab. So now, let's write the completely factored form. First step, you write the greatest common factor. Next step, put down a set of brackets, and you're going to have as many terms in the brackets as you have in the original. Take 20a squared divided by 4a, gives you 5a. And usually, I don't do the division explicitly in my head. I just say 4a times what will give me 20a squared. So 4 times 5, a times a. Plus, to get 28, we need a 7. I've got an a, so it's just going to be 7b. So 4a times 5a plus 7b. There is nothing in common here. There's no number that goes into both 5 and 7, and they do not share a common variable. Quickly multiplying this out, not foiling because it's not binomials, we get 20a squared plus 28ab. Check, check. What's the greatest common factor of 12x squared y, 18xy squared, and 24x cubed? So we're looking for the greatest common factor of 12, 18, and 24. Could do a factor tree, but I think we can recognize that 12 goes into 24, but not 18. So the number is 6. Goes into 12 twice, 18 3, and 24 4 times. We say they do all have an x in common. We're going to go with the lowest power of x. And they do not have a y in common, so there is no y in the greatest common factor. So 6x is it. So let's write the fully factored form. Start with 6x. Now, how do I get 12? 2. how do I get x squared? X. How do I get the y? Y. Minus, this sign is going to continue. 18 divided by 6 is 3. The x is already there, so I don't need to multiply it by another x, but I do need a y squared. Plus, and these signs are going to be identical to the signs that are here, unless you had a negative out front, which would change the signs. Okay, 6 times what gives you 24? 6 times 4. X times what gives you x cubed? X times x squared. And now we look, are there any common factors? Is there a number that goes into 2, 3, and 4? No, there isn't. I have an x, but no x, and I have an x. So all 3 terms do not contain an x, and only 2 of the 3 terms contain a y. So this is the completely factored form, right? In other words, when you look in the brackets, there is no more common factor. If you look and you find one, then you're not quite there. You just need to take that out, multiply it with this, and then refactor. For example, Jeff was asked to write the polynomial 3x squared minus 6x completely factored form. He gave his answer as recognizing that he could divide by 3. Greatest common factor was 3. He's got x squared minus 2x. Now, we note, hang on, this expression can still be factored. There's a common x. So is it in factored form? Yes. Is it completely factored? No. And whenever we say factor, we mean completely factored. Okay? So understand that. Whenever you see the word factor, you need to think completely or fully factored. Fully. Explain Jeff's mistake. So his mistake was that he did not take out an x. That the largest, let me just clean this up. Actually, I want to be looking here. That the greatest common factor is 3, and they share an x in common. So, Jeff did not factor out the x. So let's give a complete answer. So I'm going to write 3x squared minus 6x is equal to 3x. That's the greatest common factor, x minus 2. Okay, again, we take 3x squared divided by 3x. So 3's cancel, and you're left with x squared over x, which is just x. Or more likely, and I find more easier, is to say 3x times what gives me 3x squared? 3x times x. 3x times what gives me the 6. Now this sign just continues, right? That sign's a minus, so 3x times 2 gives me 6x. So 3x squared minus 6x. And I'm going to advise every time you factor, look to see that it's fully factored, right? That you didn't leave a common term or a common factor. And then just quickly multiply it out in your head. Is this in factored form? Well, it's written as a product. I've got a term. So sometimes I just like to throw brackets in there. Is it completely factored? No, because they all have a factor of b. Number-wise, we're good. 3, 4, 5. Nothing common there. So is it completely factored? No. Explain. Did that verbally. And write in completely factored form. So it'll be 3ab squared times 4. Okay, now all I've done really is taken a b out of the brackets. So the b minus 5a minus 3. Okay, now again, if you think about, all right, I want to multiply this out to check, then you're going to get here, 3 times 3, you get 12a b cubed. Here we get 12a b cubed minus 15a squared b squared minus 15a squared b squared minus 9ab squared minus 3 times 3 is 9ab squared. So the original mistake was not to factor a b out. It was left and it needs to come out. So we're just taking a b out, making that 3ab squared, and then we adjust by dividing each of these by b. 7. Is this in factored form? Yes, it is. Is it completely factored? No, it is not, since there is a common factor of 2 inside the brackets. So remember, when we're done and we think, hey, I've got factored form, then you just need to look and say, oh, wait, I can take a 2 out. So 2 bracket x minus 2, 2x minus 4 times x plus 3. Remember, factoring is writing it as a product, and fully factored means that there is no common factor within a set of brackets. Factor completely. Remember to check your factors to see if they can be factored further. Okay, 12 and 15, the biggest number that goes into both of those is 3, and they do share x. How do I get a 12? How do I get an x squared? And here we go. Oh, whoops. Too far. Can I pick this whole thing up? Okay, that's the factored form. And the GCF is really 3x. Okay, so first, the greatest common factor is 3x. Write that down, and then the factored form. However many terms there are here in the simplified form, that is how many terms you will have in the parentheses here. Okay, what goes into 35 and 40? I think 5 is the greatest common factor. And then it's basically the lowest power of the variables, so m cubed. Write the greatest common factor, 5m cubed. This will be 7. 5 times 7 is 35. I want m to the 4th, so 7m minus, because that sign carries over, 5 times 8 gives me 40, and I've got the m cubed. 7 and 8 share nothing in common, and there is no variable in both, so it is fully factored. Multiply it out, 35 m4, right? 3 plus 1 is 4, minus 8 times 5 is 40, m cubed. Check and check. We have 3 terms here. So notice variables are all different, a, b, c. So 4 goes into, our greatest common factor can't be any larger than our smallest number. So 4 is our greatest common factor, 4. This will be 4a plus 6b minus c. Anything common? No, letters are all different, and we got a 4, a 6, and a 1. And if you ever have a 1 in here, then you know you've gone as far as you can, right? There's nothing that will be common. Check it out, 16a plus 24b minus 4c. Yes, yes, yes. Okay, we need the largest number that goes into 30, 12, and 18, so I'm thinking 6. We need the smallest power of p, because it will divide evenly into all of these powers of p. 6p cubed. Okay, how do I get a 30? We got a 5, and I want p to the 4th, be 5p, minus 2. I want p to the 7th, so I'm going to need p to the 4th, minus 3, because I got to get 18, and this already has the p cubed, right? That's why it's the lowest power, because it won't be needed in here. There won't be any p. Okay, expand. So 5, 2, and 3 do not share any common number, and this has a p, this has a p, this doesn't. So again, this is fully factored. 30, p to the 4th, check. Minus 12, p to the 7th, check. Minus 18, p cubed, check. All right, and that's the way you can check, right? We check to see if they can be factored further. They can't, and we check to see that we have the correct factorization. 30 and 20. I think 10 is the number that goes into 30 and 20. A, they both share an A, so we'll go with a to the 4th. They both share a b, and we'll go with the lowest power of b. Remember, we want the b squared to go into both, and it'll go into this for sure, but if we use b to the 6th, it would not go into this. And this has a c, this doesn't. Okay, so you write down the greatest common factor. That's your first step. And then you say, how do I get 33? How do I get a to the 10th? I need a to the 6th. How do I get b squared? I've already got the b squared. And how do I get the c? Minus 2. Notice nothing common between the numbers, 3 and 2. How do I get a to the 4th? Already there. How do I get b to the 6th? I put in a b to the 4, remembering that we're going to add the exponents. Okay, this has an a and a c. This doesn't, has a b. No a, no c, so nothing common, and 3 and 2 are prime, so nothing common there. Multiply it out, 30a, add the exponents, so 30a10, b2, c. 30a10, b squared, c, minus 20a4, b6, done. Oh, here's a tricky one. So x cubed, or actually we guess we could say negative x cubed is our common factor. Write that as negative x cubed. This gives me x squared plus 1. Now, could you leave the negative? So just say, hey, x cubed will go into both of those. X cubed negative x squared minus 1. I would prefer if both terms in the brackets were negative that it just come out. In either case, multiply, we get negative x to the 5th minus x cubed, which is what we want, or we get negative x to the 5th minus x cubed. And here you'll notice no common factors inside the brackets, so fini. The algebraic expression 3x minus 4 plus 6 is neither factored nor simplified. Should it be a nor? Neither nor? I don't know, that's just messy. Write in simplified form, so we have to multiply this out. 3x minus 12 plus 6. So 3x minus 12 plus 6 equals, which is going to give us 3x minus 6. That's simplified form. If we want a factored form, we first need to simplify and then take out the common factor of 3 and write 3x minus 2. So given an expression which is neither factored nor simplified, simplify it first, factor the simplified form. Okay, let's complete the table. If that's the factored form, then I need to multiply this out. So the simplified form is 4x squared minus 5x. If this is the simplified form, the common factor is m cubed. There's no number in common since you can't, no number goes into both 7 and 4. I want to get m to the 6th, so I need an m cubed. Remember your rules, right? I'm going to add the exponents, minus 4. And that's 7m to the 6th minus 4m cubed. Check. This will be 15a minus 20b plus 5c. And that is the simplified form. Just multiply out the factored form. This, all I see in common, I mean there's no number in common between 7, 8, and 5. That's prime, and that's all 2's. 2 times 2 times 2. So all we have is the letter a. So 7a, right, that's how I'm going to get a squared, minus 8b plus 5c. 7a squared minus 8ab plus 5ac. Seriously, anytime you factor, you have to check the factorization. It doesn't take long, and it makes sure that you have things correct. Okay, this is a factored form. Notice we got an a, but no a. These two terms have b's, but this one doesn't, and 1, 5, and 4, there's nothing that goes into them. So we get 20a cubed b squared. 20a cubed b squared plus 4a squared b cubed plus 4a squared b cubed plus 16, 4 times 4, a b cubed. A b cubed. Well, squashed in there. That's an a. 16a b cubed. That's what that says. One more time. 4 times 20. A times a squared is a cubed. B squared plus 4. A squared b cubed plus 16. A b cubed. Yes. Check, check, check. And this needs to be factored. So the largest number that goes into 40, 24, and 56. So I know 4 goes into all of them. I know 8 goes into this, 8 goes into this, and 8 goes into this. So I'm thinking it's 8. Actually, you know what? Let's, for the heck of it, let's just say that I choose 4, right? So let's see what happens if you don't choose the greatest. So 4. X, I need the smallest power of x, which will be x cubed, since the smallest power of x will divide into all of these, and the smallest power of y is y squared. Okay, 4 times 10. I want an x to the 4th, and I need a y cubed, so 10xy minus 6. I need an x to the 5th. So, I'm looking at what adds, right? And then I need a y squared, which is good. Plus, and 56 divided by 4 is 14. I need an x cubed. I've got that. I need a y cubed, so putting a y in. Now, when I go to look here, x, no x, y, no y. That's good. But wait a sec. All of these guys are even. So I say, okay, I could take a 2 out of that, and a 2 out of that, and a 2 out of that, which means that I really need an 8 up front. So that's what I should have started with, was the 8. And then, we can go in and just redo this, divide each of these by 8, or we can say I pulled a 2 out of here, 5xy. I pulled a 2 out of here, 3x squared. I pulled a 2 out of here, plus 7y. 5, 3, 7. That's odd. It's also they're all prime, so there's no number that goes in, and same as above, we've got an x and x squared. We've got the y's here and here, but no y here, so we're done. Check it. Okay, quick multiply. 40 x to the 4th y cubed minus 24 x to the 5th y squared plus 56 x cubed y cubed. Okay, and if what I read back was this, this, and this, then we're good to move on. So far, we've only explored a common factor that is a monomial. Can there be common factors that are binomials? So looking here, number-wise, no number, but there is the capital letter A. So A, and then we've got 5x minus 3. Okay, now, if we use similarities from part A to help you factor this, you can say, what's common here? The y minus 2 is common. It's in both terms. So the common factor is y minus 2. And what are we left with? Well, think of the A as being y minus 2. And y minus 2 up here, right? So we take out the A, which is the y minus 2, and we're left with 5x minus 3. So you see how these parallel? And sometimes this becomes a strategy that we may use a lot in factoring, which is to replace something, to say, I don't like seeing y minus 2, so I'm going to rewrite this as 5x times a minus 3 times a. And that I can factor. And then I can take it to what it should be. Okay, so it's a method of problem solving. George Polya said was solve a simpler problem. Okay, simplify this. Okay, multiply it out. So we get 5xy minus 10x minus 3y. Remember that minus sign here will change the signs, and this will be plus 6. Now notice, there's 4 terms, there's nothing that collects because we have an xy, an x, a y, and a 6. Simplify the factored form of y minus 2. So this factored form, we want to simplify it. Y minus 2 times 5x minus 3, right? Which is multiply 2 binomials together. And we get first 5xy, so equals, I guess we could use an equal sign there. Outside, minus 3y. Inner, minus 10x. And last, plus 6. And you'll notice the order's a little different, but it's the same 4 terms. So are they the same? Yes, they are. We can write the terms in any order, just as long as, you know, when it's a minus 10x, it has to be a minus 10x to say they're the same. Factor completely the non-factored form. So we have a binomial common factor, which is 2n minus 5. And what's left? 4m plus 7. We have a common binomial factor of x plus 3. And what's left? 2x minus 7. We have a common binomial factor of a minus b. Okay, since they're binomial factors, make sure it's always in brackets, right? We're always going to bracket our binomials. What's left? X plus y plus z, right? Because there are 3 terms here, so it's going to be 3 here, which will give us that trinomial. And x minus 5. Oh, wait a sec. Well, we got a 2, so let's common factor first. Let's take a 2 out, giving me, I'm going to throw down a square bracket, x bracket x minus 5 minus 2 bracket x minus 5, which is equal to 2. That's common. Then pull the x minus 5 out as common, x minus 5. And then what's left? We've got x minus 2. Okay, now we could do this another way too. We could have just said, all right, common factor is x minus 5, and you're left with 2x minus 4. And you got to say, oh, hang on, to completely factor this, I need to pull a 2 out. So 2, and then x minus 5, and then x minus 2. Does the order of these matter? Not really. Okay, you could have written the 2x minus 4 first. These could be written in any order, but you better lead with a number if there is a number. Do a check for part C. So I guess doing a check means, let's expand this out. XA minus XB plus YA minus YB. Okay, hang on. Violation, violation. Okay, when we're going to multiply, if we want to be looking at the same thing, so XA, we're going to call that AX minus BX plus AY minus BY plus AZ minus BZ. Right? So let's keep terms in alphabetical order. There's nothing that collects together. There are no common terms. Now let's multiply this out. So remember, binomial times trinomial. We get AX plus AY plus AZ minus BX minus BY minus BZ. We got AX minus BX plus AY minus BY plus AZ minus BZ. Okay, so that is a check, right? We have checked it out by expanding the factored form, and the, well, it's not really a simplified form, is it? The non-factored form. Okay, factoring a polynomial where there is a common factor. Step 1, find the greatest common factor. That is the largest expression that divides into all terms, right? So the biggest number that goes into every number, and if a variable is common, the smallest power of that variable that's in any of the terms. And then write it down. Then put down a set of brackets and divide each term by the GCF, writing the answer in brackets as a product of the GCF. Remember, there will be as many terms in the bracket as there are terms in the original expression. Check your answer by multiplying. If the original expression is not in simplified form, the way to check is to multiply both the original expression and your answer to see if they are equal. And this concludes common factoring. It's the first step in any factorization that you're going to do. Sometimes we might forget to do it, but in the end we'll be reminded because we will see that we have a common factor left in our set of brackets. So most important right now, factoring is common factoring, and I'm going to say when you factor, it's common factoring first, always. Okay, I want it to be done by 7, and it is.